Okay, sure. Again, I'll revise. So what are the components we have in the two-tier architecture is very simple, client and server. What is the problem with the client server architecture is there is no security, no scalability, no performance, very small. So previously before 2000, we used to have only 100 people or 200 people may go to the bank and they may use those applications. Okay, not everyone are going to use. Okay, and not centralized, not from my home I can access. It's not internet banking. So if I go to the bank, they're using these kind of applications. Or if I go for airport, in that airport they may be using. But we got the web-based applications. With that, we started using three-tier kind of architecture. But before that, we don't have the technology for the web-based applications. Which technology bring the web-based kind of concept is? Which technology bring that? So mostly the Java technology. So Sun Microsystems has bring the Java. With that, mostly the web-based applications have been developed. Till the time we have Pascal, COBOL, DB2, VB, most of the mainframe kind of systems we used to have. But later we got Java, ASP, PHP. That's all bring three-tier kind of architecture. With the three-tier architecture, we have mostly three layers. One is presentation layer. Second one is business layer or application layer. Third one is database layer we have. Okay. The presentation layer, mostly on the client side, user can have a browser or some endpoint application we can have. And here also we have two terms, thin client, and thick client kind of concept also we have. What is the difference between thin client and thick client is thin client doesn't store any details at least. Okay, thick client may store some UI kind of things. It's easy to only important data it retrieves from server. Okay, but thin client, everything will retrieve from server, which will take more bandwidth and which will improve the optimization of bandwidth. All this thin client will consume. Thin client will consume more bandwidth. Thin client, thick client is what is the meaning of thick client? Thick client will have some data. Maybe say suppose you open Twitter app in your mobile, all the old data it can store itself. Okay, if you don't have internet also, sometimes offline we can access that kind of content, all those. Each and every time we no need to download. Okay. Then what is the business logic? So business logic or application logic is like here again we have two terms here. We have web server and application server. So what is the difference between web server and application server is web server is only for the static web content, whereas the business logic has been running in the application server. Okay, so here in the business logic or application layer, we will have two types of servers. One is web server and application servers. In our application architecture, we can have either both or we can have only one itself. Okay, we can have only either web server or application server. Both may reside in the single server or two different kind of servers also. Okay, then finally we'll have the database layer, a centralized RDBMS. We will have centralized RDBMS we have, and we are going to use the database layer also we are going to use. Okay, so what is the main advantage is it's a web-based kind of technology over the browser. We can host that application from anywhere and we can use those applications. Okay, so today most of the applications or websites have been .com kind of companies, products, startups. Okay, everyone got success is through these kind of web-based technologies itself. But in the three-tier itself, we don't get the scalability and enterprise class kind of scalability. That means maybe 1,000 users or 10,000 users is may work fine. But today, millions of people are going to use some websites. Even billions of people also are going to use. Okay, so for that, what we need to do is, for that, what we need to use? We need to use the centralized RDBMS kind of solutions. Okay, say any RDBMS databases, So we have the leader is there, Oracle is there, Oracle SQL database we have. Otherwise, Microsoft having Microsoft SQL server we have, or MySQL we have, PostgreSQL. So these all the databases. Even IBM having DB2 we have. Okay, so these all the different databases we have, and centralized databases we are going to use. The application logic is different, business logic is different. With that, we are going to get more scalability and a centralized kind of database. That is the reason web-based applications are becoming popular. But they can't meet the enterprise class scalability. That is the reason we are going to maintain group of servers as the clusters. So what is the advantage of maintaining group of servers as the cluster is? Even if one server goes down, the solution is highly available from another server. Okay, so for that, in the entire architecture, we are going to maintain group of servers mostly attached to a load balancer. So what is that load balancing also we'll discuss. But here all these servers have been attached to one server. What is the main advantage with this is, even if one server goes down, the solution is highly available from another server. Even if one server goes down also, the solution is highly available from the other servers. Today, mostly like any of the application in the real time, or whatever the applications you are using also, mostly they have entire architectures. Okay. And compared to the three-tier kind of architectures, say in the three-tier, third layer we have is the database, right? So it's not only the database we have. Today we are going to communicate with the NoSQL kind of servers, and we have like a reporting kind of servers, and Active Directory, LDAP we will call that as. Okay, say monitoring kind of things, SNMP kind of servers. Okay, so then third party APIs. Say now, I'll tell one example. Say if you join in a company, they'll give their say maybe at the rate of Wipro.com, or at the rate of Cognizant.com, say CTS.com, like that, whatever it may be, their email ID we have. That is not going to store their username and passwords in the their username and passwords are not going to store in the those username and passwords are not going to store in the database. Where those details are going to store? Any idea where those details are going to store in the real time? Where they're going to store in that details? So normally we'll have Active Directory. Okay, all the, if you join in the company, all their, say suppose in my company if I have 1 lakh employees, all their 1 lakh employees details, their computer details, all those are going to store in a centralized location. That is called as Active Directory, or we can call this as LDAP, Lightweight Directory Access Protocol. Say, can you tell me web server or application server? Which server will communicate with LDAP? Which server will communicate with LDAP? Web server will communicate or application server will communicate? With the database or with the, like say suppose here, the client to web server. But even in the middle, we'll have DNS servers, load balancers that we'll discuss. Then web server to application server. Application server will communicate with the database or LDAP or maybe with the third-party APIs or third-party applications. Who will communicate? Web server or application server?
Application server.
Application server. Web server is only for the static web content. What is the meaning of static web content? What is the meaning of static web content? So what is the meaning of static web content is, if I use the HTML, okay, or maybe React JS, Angular JS, that doesn't have any business logic. For everyone, I'll display the same content. Okay, say here HTML style sheet, cascading style sheets, or bootstrap kind of content, okay, or maybe Angular kind of things, or React JS. Okay, these all comes under front-end kind of technologies. In order to handle that kind of web request, we need the web server. But I have some business logic. So that business logic will write using programming language. Okay, so can you tell me which type of programming language? Is maybe using Java or .NET or maybe PHP or Python kind of things, or we may have a Go language or Node.js. In JavaScript family, we have the Node.js. So these all the mostly used programming languages. So mostly we may have Java, Node.js, .NET, Python, Go language. Okay, so these kind of, in order to run this business logic, what we required is, okay, we need application servers. In order to run that business logic, what we required? Application servers we required. So normally we will have both the web servers and application servers we have. Okay, so these kind of application servers also we are going to use. Okay, so then in order to run that business logic, we are going to use the application servers. Application servers will communicate with the database also. So now here we may use the word called JDBC or ODBC. If it is .NET, we have ADO.NET. For PHP, we have PDO kind of .NET, PDO kind of connectivity. That means that application server need to establish a connection with the database. It's not only with the database, it can communicate with Active Directory and APIs. I'll tell one example. Everyone are maybe using like Mintra app or maybe another like Flipkart kind of app. It can communicate with Gmail or Facebook credentials. Is it right or not? So your Mintra app maybe log in with Facebook app. That means Mintra application server is communicating with Facebook API, whether that login is working fine or not. or we can log in maybe with the Gmail also, with the Google credentials, you may log in. Otherwise, I want to send the payment, then I may use PhonePe or PayPal or maybe any banking kind of things. Okay, these also the third party APIs itself. With all those components also, which server will communicate? Which server will communicate with all those? With all those servers, application server itself is going to communicate. Okay, any doubts? Any doubts till now? So mostly with the APIs, with all these also, like application server will communicate. Even there may be lot of other terms also, other servers also. Okay, so maybe we'll have message queues or middleware kind of technologies. All those also going forward we'll discuss. Then we may have reporting servers also. I want to generate 1 month report or 1 year report. Mostly that's we have the reporting kind of technologies also we will have. Monitoring also, SNMP, simple like network monitoring kind of protocols, SNMP servers also, monitoring also is very required. Log collections also is very required. Okay. So those also all we are going to maintain here in our application. Not only web servers, application servers, we'll have load balancers, and very importantly, we'll have DNS servers. In order to deploy all these, okay, we need computing. Who is going to provide that computing environment from AWS? Who is going to provide that computing environment for us in AWS?
EC2.
Yeah, EC2 is going to provide. I hope you understand why we are going to use the EC2, right? Why we are going to use the EC2 is like in order to deploy our applications and websites, all these we are going to use the EC2 instance. Okay, so for that, if you maintain hundreds of servers, it takes a lot of time and a lot of resources. That's we are going to automate by using EC2. More automation we are going to do. Okay, so these all like here first we need to understand we have some of the servers are web servers, application servers, then we have RDBMS, maybe we'll call as database servers, and we are getting popular NoSQL kind of databases also we are getting popular. Active Directory, we will have DNS. So some of them are DNS servers, Active Directory servers, and SNMP for the monitoring kind of servers we will have. Okay, so reporting servers, message queues. What is this message queues also will get? Okay, so these all third party, and we may have other B2B also. What is the meaning of B2B here? Business to business. Say maybe say one car dealer is there. Okay, or car company maybe dealing with the hundreds of dealers. Between them, they may have some applications that comes under like B2B kind of applications. So there is one more term, B2C. What is the meaning of B2C? Business to client or customer. Directly we are using that application. Directly the end users are going to use that application. Okay, so now in order to communicate with the B2B kind of applications, the dealer may have one website, that car manufacturer may have one website. Both also need to communicate with each other. Both also need to communicate also. So mostly we will have our applications will have mostly B2B applications we may have, or B2C applications also we will have. Okay. Yeah, any doubts now? Try to ask if you have any questions. So these all we need to maintain for an application. For that, we need the computing. In previously, we used to maintain the physical servers or virtual servers. Now we are going to use. So now we are going to use the. We need to use the physical servers or virtual servers before. Now we are going to use the EC2 instances. Okay, so for all these, maintaining EC2 instances also is becoming very expensive. Now we have the serverless also, or we are going to use microservices also. But as of now, we are taking EC2 instances, and using the EC2 instances, we need to deploy, high scalable and high available applications. So that means we are going to architect, like to deploy the high available and high scalable applications. How to design that we need to discuss here. For that, we are going to use EC2 instances. Yeah. Any doubts on this? So in our EC2 instances, we need to install the web servers and application servers. Even try to tell that we have different web servers in the market, different application servers we have in the market, SQL or relational databases or NoSQL kind of message queues we have. And we have a lot of technologies have been coming, and project to project is maybe keep on changing also. But that infrastructure is required in order to run the computing of all these. We need to run some of the machine learning kind of tools, data science kind of tools also. On top of this, we are running. Okay, for all that also we need the computing. For all that also we need computing. For that, we are going to use EC2 instances. I hope you understand, right? Why we need to go for EC2 instances. Then we'll take the web server, or first, if you able to connect it to those servers, then we need to install the web servers and app servers. Then we are going to deploy the applications. So we need to take Tomcat and different kind of applications also we need to deploy. Okay, so then what are the operating systems we have? Mostly is Linux and Windows. Mostly we are going to use Linux itself for all this. We are going to use the The Linux itself we are going to use compared to Windows. So in the Linux also we have the different flavors, right? Can you tell me some of the flavors? Can you tell me some of the flavors?
Red Hat, Ubuntu,
Red Hat,
Linux.
Ubuntu. That depends upon the project architecture we are going to choose. Some of the people will choose Red Hat. Some of them may use Linux. It depends upon the company. We need to choose which one we are going to select. Okay. So then, like, what are the leading web servers we have in the market? Okay. So coming to the web servers we have in the market, we have Nginx is there, or before that itself we have Apache. Okay. Say, or this itself is called as HTTPD. Okay. Nginx or Apache are the leading web servers we have. Okay. On Microsoft, we have IaaS. Excuse me. Internet Information Services. This is on top of .NET we have, or for .NET based applications, or for Windows based we have IaaS, and on top of Linux we have mostly Nginx or Apache we are going to use. Okay, but what IaaS can do is IaaS can act as both web server and application server also. Both it can act as the web server and application server. Both it can do, but there are some servers which can do only web server kind of job role. Some of the servers only can do application server kind of job role. Okay. So here we are going to get like both also in the same server we can reside. That depends upon the architecture we need to work. Some of the servers are web servers, some of the servers are application servers. So mostly first, I have shared one video for the web servers and application servers. That's we need to finish. In that, we need to install Nginx, Apache, Microsoft, IaaS. Okay, so these all we need to install. Okay, so once we install those web servers, and if you have 10 web servers also, if you have 10 web servers also, there is no use. Okay, for the scalability, what we need to do is we need to attach them to a load balancer. Okay, if we don't have the load balancer, then the end user doesn't know to which web server you need to connect. Hence, on behalf of all web servers, okay, we will have one front end kind of communication channel, that is our load balancer. Okay, that means whenever we hit the Flipkart, when we hit the Google, like mostly they'll hit first load balancer. What load balancer will do? Load balancer always will redirect the traffic to the healthy instance. It's going to send whatever the traffic we have sent. It is going to communicate with the load balancer. What is the main advantage with the load balancer? What is the main advantage with the load balancer? Okay, so whenever the user types the load balancer, we no need to worry about the 1,000 servers or 10,000 servers we have in the backend. Who will take the decision to redirecting the user traffic to the healthy server? Load balancer will take care. Okay, so load balancer will take care that one. What is the advantage with that is What is the advantage with that? If one server goes down, okay, end user doesn't have any impact because that server is not given to that user. Okay, that server is not assigned to the user. The load balancer always will take the decision of redirecting the user traffic to the healthy instance itself. Okay, so that is the purpose we are going to use. That is the purpose we are going to use. Load balancer we are going to use. Okay, previously we have HA proxy is one of the load balancer, or Nginx also. Nginx is not only the web server, it can do the load balancing also, or we have hardware based load balancers also we used to have. Hardware based load balancers also we used to have, like Citrix having Netscaler, or F5 load balancer. So these all the hardware-based load balancers also mostly the companies are going to use. But today we no need to worry about those also. Cloud itself now provides, AWS or Azure itself is providing the load balancers also. Okay. So what is the concept of the load balancing is? Load balancers always will take the request from the client side and redirect the traffic to the healthy instances itself. Always it's going to redirect the traffic to the healthy instances. And even in the backend, if any of the server is down also, that server is removed from the load balancing. That server is removed from the load balancing. So that is the main advantage to go for load balancers. Okay, so that is the main advantage to go for the load balancers. Okay. Yeah. Any doubts on this? Any doubts? Okay, so here in the cloud also we are going to get one more term. In the physical servers or virtual servers, getting elastic kind of capability is not so easy kind of thing. Okay, but in the cloud, we can get elastic also. That means I'll tell one use case. So suppose I have a load balancer, and load balancer having only 3 servers as of now. But I got more load, then automatically I'll increase to 10 servers. Even I got more load, I increase to 100 servers. Okay, so what we are doing is, here we have a load balancer, and that has been attached to auto scaling group also. And that auto scaling group, what it is going to do is, automatically depends upon the load, it is going to scale up those servers. Okay, it is not that much easy in the physical or virtual kind of infrastructure. Who can provide this is in the cloud we are going to get. Okay, so that is, we already discussed, we have one term called auto scaling, right? Auto scaling comes under horizontal auto scaling or vertical kind of auto scaling. So we can have both the horizontal and the vertical auto scaling, but increasing from 3 to 10 servers, 10 to 100 servers, This all comes under, can you tell me whether this comes under vertical scaling or horizontal scaling?
Horizontal scaling.
Yeah, horizontal scaling. And whenever we are going to access our website, mostly we are going to use the HTTP is the protocol. Okay, hypertext transfer protocol, that is the port number is 80. But one of the major challenge with the HTTP protocol is it's not secured. If you have any sensitive details, otherwise you have any sensitive kind of content, okay, your images, it's going to transfer over the internet, which is a public kind of leased lines, or maybe transfer over the public internet, then everyone can retrieve the data. So that is the reason it's not recommended to use HTTP. Okay, HTTPS is recommended. For that, we are going to use the port number is 443. HTTPS hypertext transfer protocol over a secure layer we are going to use. For that, we are using SSL certificates or SSL certificates or TLS also is the new algorithm compared to SSL. TLS certificates also we are going to use. Say in our job, it's not recommended to use the HTTP kind of communication. We need to use the HTTPS communication. Okay. So then we need to communicate over the HTTPS. For that, definitely we need to configure SSL certificates either at the load balancer level or at our web server level. Also, we need to configure. Then the data is going to be encrypted, and only that web server will have, or load balancer will have the server certificate. That is only can decrypt the data. Okay, so no one in the world, even in the middle, if they got the data also, they're not going to decrypt the data. The only that web server, or maybe sometimes we'll configure at the load balancer level also. Okay, that term is called as SSL offloading or TLS termination. Maybe everyone have used the debit card or credit card details, right? While creating your AWS account. If I use a normal traditional HTTP kind of protocol, then what is going to happen is in the middle, everyone may get our credit card details or debit card details. Now only Amazon server only may decrypt that. Or if they communicate with any of the payment gateway, only that server only can decrypt that data. No others in the world will get our card details. Okay, that point is called as SSL offloading or TLS termination point. Mostly we'll choose load balancers or application servers in our environment for this kind of scenarios. The term is either we'll call as SSL offloading or TLS termination. Okay. That mostly we will configure in our environment. At the load balancer itself, we will configure our SSL offloading. And we need to keep that servers in the multiple zones and multiple regions also we need to set up, because if you keep that in the single server or single zone or single region, it's a single point of crash. Okay, for this we need to maintain those servers in the Okay, so if you choose the single point of zone, what is the main advantage is, if you choose the multiple zones, what is the advantage is, one zone goes down also, the solution is highly available from another zone. Okay, we need to design some servers in one zone, some servers in another zone. Okay, and some of the servers we need to keep even in the multiple regions also. Okay, so then even one region goes down also, the complete another region we need to switch. So these all we need to design going forward using the AWS services. We are going to deploy high scalable and high available kind of applications. Okay. So for all these, we are going to use the AWS services. We have the AWS services like VPC we need to design, IAM we need to design, EC2, EBS, domain directory kind of services, message queuing, SQS kind of services, SNS kind of services. These all, like, we have lot of services in the AWS to deploy. But from tomorrow onwards, first we'll deploy these all the without like a automation, manually we'll do, then we'll go for the automation. Okay, any doubts? Okay, so today I shared one web servers related installation, all those. Everyone try to finish that, and some Linux commands. We should have very good knowledge on the Linux commands, and some Windows automation also we need to do. Then finally, networking also. And using these services, CloudWatch, CloudTrail, these also we are going to learn. Okay, so these all we'll discuss from the tomorrow session. And one more thing is, I'll share one more IAM related also. So try to finish this IAM also. Okay, so tomorrow will everyone first connect to the EC2 instances, and if you have any problem with the EC2 instance connection, try to go through again that videos. Everyone very casually should able to communicate to EC2 instances. Okay. So IAM, what is the purpose of this IAM? What is this purpose of this IAM?
Giving the access, sir.